Hi everyone, so these are the notes for 6.6, Systems of Linear Inequalities. This is the last topic for your test. So please copy the heading, and then before taking these notes, make sure that you have graph paper, a calculator, and I would suggest using 2 different colored pens or colored pencils just to kind of color code this as I am going to do in the video. It might make it a little bit clearer. Okay, so here's our first example. It says to graph the system of inequalities and label the solution set S. So the only real difference here is that we are now graphing 2 inequalities on the same set of axes as opposed to 1. Okay. If you remember earlier this chapter, we did the same thing except graphed 2 equations on the same set of axes. So you can decide how to organize this, and you should be setting up your axes as well. I'm kind of just going to split this over here and do everything for y is greater than 3x minus 2 on the left, and everything for 2y minus x is less than or equal to 6 on the right. And I'm going to keep these colors consistent so you can see how it matches with the graph shortly. If you wanted to make one big table of values for this, you could. I'm just going to, again, separate it for this example so we can see the color coding. So let's start with the one on the left. Y is greater than 3x minus 2. First of all, we should all realize that this is going to be dashed, and we now need to make a table of values for it. Okay. So -2, -1, 0, 1, and 2 are going to be my x's. Okay, so I'll give you a minute to copy that and then fill in your corresponding y's. Once you've done that, you're going to plot the points, and then using a ruler or a straight edge, connect them with our dashed line. Okay, label the line with its inequality. And now we're going to pick a test point for shading. So I'm going to just extend that line there so we have enough room to see. Okay, for my test point, pick any point besides one on the boundary line. So, for instance, I'm going to pick the point 5, 0. I'm going to plug it into my inequality. So I get 0 is greater than 13 when I simplify. So this is false. So that means if you look at my picture, 5, 0 is kind of towards the right of our boundary line. We're getting false answers. So we need to shade on the other side. And you can pick a point on the other side in order to check. We are not going to label with an S yet because we still have another inequality to graph. So now on the right hand side, first let's get y by itself. Remember to divide everything by 2 when isolating the variable. And we get y is less than or equal to 1/2 x plus 3. If you want to leave it as x over 2 plus 3, that's fine too. When making a table of values, you might want to pick some of the friendlier numbers. That way you don't have to plot the 0.5s. Okay, so you don't necessarily have to pick the same x values that you did for the first inequality. Okay, so for instance, I'm going to pick all even numbers to avoid that. And once I have those points, I'm going to go plot those. And notice I'm doing all of this in blue. I'm doing this all in my second color. And you'll see in the graph how that's going to help. This we should make a note of is going to be a solid line. And label it with its inequality, either the new one or the original. We are now going to pick a test point to figure out how to shade for the second inequality. So we need to pick a test point on either side of the blue boundary line. So I'm going to pick an easy point and do 0, 0. I'm going to plug it into the original inequality. It doesn't matter which one you pick. So this is going to give me 0 minus 0 is less than or equal to 6. 0 is less than or equal to 6, which is true. So 0, 0 is below the line, so that means I'm going to shade below the line. Now notice my stripes from my shading before were kind of going downwards as a negative slope. We want to now, for the second one, make a design that's different so that it looks like I crisscross when they overlap. Now the solution set where we label S is where they overlap. Okay, so all of the points where they overlap will satisfy both inequalities. So we can check this by picking a point within that solution set. So let's say that I pick negative 4, 0. We want to make sure it works in both inequalities. So trying it in the first inequality, 0 is greater than 3 times negative 4 minus 2. 0 is greater than negative 14. That's true. Let's try the second inequality. 2 times 0 minus negative 4 is less than or equal to 6. 0 plus 4 is less than or equal to 6. 4 is less than or equal to 6. That's also true, so those points do work for both inequalities, so we know we've completed the problem correctly. Okay, for our second example, I would like you to complete this one on your own, in addition to taking the notes. So we're going to graph the system of inequalities, and then just list a point within the solution set. So in a way, that's the same thing as checking your answer, because you're going to pick a point in that region where the two shadings overlap one another. In this particular problem, both inequalities already have y isolated. Okay, so you just need to go make your table of values, shade, and then come up with a point within the solution set. If you get stuck, refer back to the first example if you need help. If color coding helps as well, feel free to do that.